Hi folks, Mr. Long here for part 2 of our introduction into solving systems of equations with matrices. So for this second question, you can see the system right there. What we're going to do is go through the solutions for this one. Okay, I've already got the solution set up. So here's the original right here. I'll maybe highlight each equation. There's one equation. There's the other equation. So again, what am I looking for? Well, I want to see if one coefficient is a multiple of another one. So is 4 a multiple of 5? Or vice versa? No. 3 and 7? No, they're not multiples. Is there a common factor? That's something else I would ask. Nope, no common factors. So there's really not much I can do here, except what I'm going to have to do if I want to get the same coefficients, I'm going to have to, so what would I multiply 5 by, and what would I multiply 4 by so that they're the same? Well, 5 by 4, 4 by 5, right? And then I'm going to have 20x in both equations. And remember, I can get multiples of equations as long as I multiply everything by the same amount. I still got an equivalent representation. It still represents the same set of ordered pairs. That's what lines have, sets of ordered pairs. So what I'm going to do is multiply all of this by 4. So 4 times 5, 20x. 4 times 3y, 12y's. 4 times 12, 48. Do the same thing except multiply by 5 in the second equation. We have a new set of equations, 1 and 2. Okay, they're just multiples of other ones. Now I can eliminate. How am I going to eliminate? Well, I'm going to just have to subtract because both of those are positive numbers. Okay, they're both positive numbers. So I'm doing 2 minus 1, although 1 minus 2 would work. Why did I pick 2 minus 1? Because I like to, whenever possible, have a positive coefficient. It actually doesn't matter, to be honest, especially once you work in the matrices, it won't matter at all. But I like that better, so I'm going to take 2, subtract 1. So equation 2 is the second one. So 20x minus 20x, gone. 35y's take away 12y's is 23y's. 25 take away 48, or subtract 48, is negative 23. What do I need to do to both sides here? I need to divide by 23. Okay, need to divide both sides by 23. So when I do that, I get y equals negative 1. I call that a new equation, equation number 3. How do I get the x value now? I substitute it back into one of the original equations. So one of the original equations was 4x plus 7y equals 5. So I replace that y with negative 1. 4x plus 7 times negative 1 is 5. 7 times negative 1 is minus 7. So I've got 4x minus 7 equals 5. I'd have to add 7 to both sides, and I would end up with 4x equals 12. And then divide both sides by 4 to get x equals 3. So my solution is x comma y is 3 comma negative 1, and that's the solution. Okay, so that's doing it the same way from grade 10 through elimination. Let's now look at it with matrices. Okay, so as we go through this, the process is the same every time. Okay, look for a leading coefficient of 1, or a place where you can get a 1 if you common factor, and that goes in the first row always. Well, there's nothing there that I can use that's going to allow me to do that. Okay, nothing there. So I don't even have to worry about that. Well, I need to write it down. So 5, 3, 12, 4, 7, 5. Okay, dividing out common factors. There are none, so I don't have to do this. Get one pair of coefficients equal so that you can eliminate. So what are we going to do? We said from the last time we were going to take row 1 and multiply by 4. Take row 2 and multiply by 5. Okay, and if I do that, it's going to work. So again, this is the new row 1 equals the old row 1 times 4. The old row 1 can be found right there. So again, 4 times 5, 20. 4 times that 3, 12. 4 times by that 12, 48. And then 5 multiplied through the 4, the 7, and the 5. And that's going to give us 20, 35, and 5 times 5 is 25. Okay, 25. So now I have to eliminate. What am I going to be eliminating? I'm going to be eliminating x in this case. So, because remember, this represents the x column, this is the y column, and this is the constant column. Okay, and that is like an equal sign there. Okay, so then as we do that, then I've got to subtract. So which one am I going to make negative? It doesn't matter as long as one of them is negative. So I'll make it negative 1 R2 plus 1 R1. Okay, so the new row 2, and this is the old row 2. Okay, so what I'm doing is I'm subtracting. So I'm going to take the negative of this and add it to this. So negative 20 plus 20, that's 0. You know what? I'm going to do it this way. I'll make it 1 minus plus negative 1 times R1. Okay, so it's going to become R2 minus R1. That's probably easier, right? R2 minus R1. So 20 minus 20 is 0. 35 minus 12, 23. 25 minus 48, that's negative 23. Okay, so, and by the way, I don't need this row anymore. I don't need the top row as soon as I've eliminated a variable. I don't need to copy it down anymore. Okay, so so now what do I do to row 2 to make one of these a 1? Because I don't want to have, because that's x and that's y, I want to have 1y. So I'm going to have to divide that row by 23. 0 divided by 23 is 0. 23 divided by 23 is 1. Negative 23 divided by 23 is negative 1. That means y equals negative 1. Okay, again, x, y, and the constant. Okay, you can see, I hope you're starting to see that this is a lot simpler because you don't have to write down the x's and the y's, and you're just copying down numbers. So y equals negative 1. And from here, we have to figure out x the same way as before. So if y equals negative 1, I back substitute into one of the original equations. It doesn't matter which one, I can pick any one I want. Okay, so I'll go back up, maybe I'll do 5x plus 3y equals 12. So I go there, and I have 5x plus 3y equals 12. And I'll double check that that's right. 5x plus 3y is 12, that is right. So I need to replace that y right here with a negative 1. So that's going to be 5x minus 3 equals 12. 5x equals 15 because I'm adding 3 to both sides. And then divide by 5, x equals 3. So the solutions to this one are 3, negative 1. Okay, so for homework, you've got, there's just 2 questions here to do, but I'd like you to do it the old way from grade 10 and this new way with matrices. Okay, so again, in this, along the side here, you get prompts of what you want to do in each step. Okay, and you remember, if you don't have common factors, you just skip that step. Okay, so hopefully you see that pattern develop, and I'm going to have some other screencasts to come where we're doing this with a spreadsheet, and it will really speed things up, but I want you to get really good at this process-wise so you understand how to do it really, really quickly, because this will be a critical skill moving forward. Okay, folks, so make sure you do those homework pages now, and good luck.